Partial fraction decomposition, part 4. In this section, we're going to deal with examples and practice problems in 4 different categories. In category 1, we're going to decompose the rational expression and leave it as it is. We're not going to evaluate the integral. So for question number 1, we have 8 over x squared minus 11x. Our very first rule is to check whether the numerator is greater than the denominator or not. Here it is not, so we leave it as it is, but we need to decompose the denominator into factors. So here we can decompose this as we can factor out x, so x minus 11 is left over. So we have 2 factors, and we write those 2 factors here, x and x minus 11. And since x is the linear factor, which is x to the first power, so we need some constant a here. This is also linear, so we need some constant b here. So this is the answer for the question number 1. For number 2, we have 4x squared plus 5 over x minus 3 to the third power. Again, numerator is greater than the denominator, so we don't have to worry about it. Now we have 3 different factors, which is repeating linear factors. X minus 3, x minus 3 to the second power, and x minus 3 to the third power. In question number 2, we have 4x squared plus 5 over x minus 3 to the third power. Here we have linear factor repeating 3 times. So for the first factor, we write x minus 3. For the second factor, we write x minus 3 to the second power. And for the third repeating linear factor, we write x minus 3 to the third power. Since it is linear, we need some constant numerator. Likewise, we need some constant numerator, we need some constant numerator. For question number 3, we have 2x minus 3 over x cubed plus 10x. We can factor this out as x times x squared plus 5. And we have 2 factors. For the first factor, which is x, and for the second factor, x squared plus 5. For the first factor, we need a constant a, because this is linear. For the second factor, this is quadratic, so we need some linear numerator, which is bx plus c. So this is the answer. Question number 4 is x minus 2 over x squared plus 4x plus 3. So we need to factor this out. We need 2 numbers that multiplies the c term, which is 3, which is 3 times 1, and that adds up to middle term, which is 3 plus 1. So positive 3, positive 1. So x plus 3 times x plus 1 is the factors for this trinomial. And since we have 2 factors, let's write out the factors here. X plus 3, x plus 1. This is linear factor, so we need some constant a. Linear factor, we need some constant b. Question number 5. We have 2x minus 1 all over x times x squared plus 15 squared. Here we have 3 factors, x and 2 times repeating quadratic factor. So our first factor is x, our second factor is x squared plus 15, and our third factor is x squared plus 15 squared, repeating quadratic factor. And for the first factor, we need some constant a, because this is linear. For the second factor, we need some linear numerator, because this is quadratic. So it's going to be bx plus c. again we need some linear numerator, which is dx plus e, and you need to distinct each number, so pick a, b, c, d, e and the coming letter. And question number 6 is 11x over x cubed minus 10x squared. 11x over x cubed minus 10x squared. We can factor out x squared here, and if we factor out x squared here, we get x minus 10. Here we have one quadratic factor and one linear factor. The quadratic factor is x squared and the linear factor is x minus 10. For the quadratic factor we need some linear numerator, and for the linear factor we need constant numerator. This is it. Let's go to second group of examples. This time we're going to evaluate the partial fraction decomposition. So we will decompose and then evaluate. Example 1, 1 over x squared minus 1. So we need to decompose the denominator into the factors. We know that x squared minus 1 is the difference of two squares, and it is x minus 1 times x plus 1. And we have two factors, which is x minus 1 and x plus 1, and they are both linear. So for the first one we need a constant, and for the second we need constant b. So we know that this fraction is equal to this partial fraction. Now we need to solve for a and b. So we know that 1 over x minus 1 times x plus 1 is equal to some constant over x minus 1 plus some constant over x plus 1. Now we will multiply whole equation with the LCD. Our LCD is x minus 1 times x plus 1. Multiplied by the first fraction, we obtain 1. Multiplied by the second fraction, this cancels out. We get a times x plus 1. Plus, multiplied by the third one, this time x plus 1 cancels. B times x minus 1. Now we can use the method for giving value for x. Let x be equal to negative 1. So if x is negative 1, this is going to be 0, and a term will be 0. 1 will be equal to negative 1 is negative 2b. So here b is equal to negative 1/2. This time let x be equal to positive 1. Then this term goes to 0, and it's going to be 1 is equal to 2a. Then here a is equal to positive 1/2. Now we can rewrite as a 1/2 and b negative 1/2. So our original question, which is 1 over x squared minus 1, the x is equal to 1/2 over x minus 1 plus negative 1/2 over x plus 1. And you can separate the integrals at the dx's. So here we're going to deal with this. They are both ln. If you do use substitution, you're going to see that that is ln, or you can practically see that 1 over x is ln. We can pull 1/2 to the front, and then it's going to be ln of x minus 1 plus, and that's going to be minus actually, ln of 1/2 ln of x plus 1 plus c. Let's see example 2. In example 2, we have 4x squared minus 9. This is again difference of two squares, because this is the squared form of 2x and this is the squared form of 3. So 2x minus 3 times 2x plus 3. And we can rewrite it as 2x minus 3 plus 2x plus 3. We need some constant numerator a because this is linear. We need some constant numerator b because this is linear. Now we know that 1 over 4x squared minus 9, or you can write in the factored forms to see better if you want.